one? You know, when you fire up an app on your phone, what's really going on in there? It's easy to think of it as just one single brain doing all the work, but that's not the whole story. Today, we're going to meet the whole team, a group of specialized minds that make all of our modern tech possible.
So, to get our heads around this, let's start with a simple idea. Think of your computer not as one single brain, but more like a high-tech workshop. And inside this workshop, you've got a whole team of specialized minds, each one an expert at a very specific thing. So, if we really want to understand how everything works, from the phone in your pocket to the massive data centers running AI, we've got to meet the team. Let's get to know these digital minds.
All right, let's start with the generalist of the group, the master craftsman, the workshop manager who can kind of do a little bit of everything, and that's the CPU.
The CPU. You've probably heard of it, right? The Central Processing Unit. This is what we've always thought of as the brain of the computer. It's the ultimate jack of all trades, juggling a ton of different jobs to keep the whole show running smoothly. You know, everything from launching your programs to managing your files. But what's really interesting is how it thinks. A CPU's style is all about serial, step-by-step reasoning. It tackles problems one at a time, using really complex logic for each step. You can picture it like a detective, carefully solving a puzzle piece by piece, one logical deduction after another. And that very specific, methodical way of thinking is exactly what makes it the indispensable manager of the whole operation. I mean, it's running your entire operating system, whether that's Windows or Android. It's handling all the inputs and outputs, and it executes all that tricky, decision-based logic that the other, more specialized guys just aren't designed for. Okay, so we've met the manager. Now let's meet the powerhouse of the team, the GPU. This one is an absolute expert in doing tons of things all at once. The GPU, or Graphics Processing Unit, is built completely differently. See, instead of having just a few really smart, powerful cores like a CPU, a GPU has thousands of simpler cores. And the key is, they all work in parallel. Now, it was originally designed, as the name suggests, for rendering graphics, but it just so happened that this architecture was an absolute game changer for AI. So what does its thinking style look like? Well, it's all about massively parallel processing. So forget about one complex thought at a time. The GPU is all about having thousands of simple thoughts happening at the exact same moment. It's like having an entire army of workers, where each one tackles a tiny, repetitive piece of a giant job simultaneously. And this approach, this ability to do so much at once, is why it's amazing at graphics-intensive stuff like 3D rendering. But it's also the perfect way to train massive AI models, right? Because that training involves doing millions and millions of very similar calculations. And that is exactly why the GPU pretty much became the engine that powered the whole AI revolution. All right, now it's time to meet the newest members of the team, the AI specialists. And these guys are different. They aren't generalists, and they weren't originally built for something else. Nope. They are custom-built, highly trained experts designed from day one for a single purpose: AI. Now, both the TPU and the NPU fall into a special category of chip called an ASIC. It stands for Application-Specific Integrated Circuit, which, yeah, it's a mouthful. But all it really means is that the chip was built for one and only one job. And because of that laser focus, they are unbelievably fast and efficient at that one thing. Let's look at the TPU first, the Tensor Processing Unit. This was developed by Google, and its thinking style is all about a very specific kind of math. We're talking matrix and tensor math, which is literally the language of neural networks. So you could say a TPU thinks in the native tongue of deep learning, which makes it incredibly fast for training those huge AI models. Then you have the NPU, the Neural Processing Unit. Its thinking is also super specialized, but its goal is different. The NPU is all about energy efficiency. It's designed to run AI models that are already trained, that's a process called inference, and to do it right there on your phone or your smart device without completely draining your battery. So here's the key takeaway for these two. They're both AI specialists, but they play in completely different fields. The TPU is the heavyweight champion in the cloud, using its raw power for massive AI training. The NPU, on the other hand, is the nimble expert living on the edge, in your smartphone, your car, all the devices you use, giving you those quick, real-time AI results without burning through power. Okay, so you might be thinking, if these new AI chips are so amazing, why do we still need the CPU and GPU? Why not just use the specialists for everything? And that is a fantastic question. I mean, it makes sense, right? A specialized tool is usually better than a general one. But the answer to this really gets to the heart of where computing is headed. The thing is, no single chip is the best at every single task. A specialist can't also be the general manager, right? That's why modern tech relies on teamwork. It's a strategy called heterogeneous computing, which is really just a way of saying you let each different processor do what it does best. Let's make this super concrete with a real-world example you do all the time, taking a picture with your smart camera. First, the CPU, or generalist, fires up the camera app and gets the system ready. Then, the GPU, the parallel worker, kicks in to process all that visual data so you can see a live preview on your screen. You go to take the picture and bam! The NPU, the AI specialist, instantly recognizes a face in the shot. And then, to finish the job, the CPU steps back in to save the final photo. See? The whole team working in perfect harmony. So let's just boil it all down. What's the core idea for each of these minds? The CPU, that's logic. The GPU is all about parallelism. The TPU is fluent in neural math. And the NPU brings it all together with real-time AI. And really, that's the big takeaway here. These processors aren't competing with each other. They're collaborators. The future of computing isn't about finding one chip that can do everything. It's about building these hybrid systems where each type of processor can shine in its own unique way. And that kind of leaves us with a final, pretty cool thought. We've already assembled this amazing team of digital minds. So the question is no longer just about making each one faster. Now it's about making them work together in even smarter, more seamless ways. Which makes you wonder, what new kinds of thinking will our technology need next?